All right, today we're going to be covering password cracking and all the aspects of passwords in general. So to get started, when you put a password into your computer, the computer doesn't store it in plain text or what you would type in. Because if anyone could get access to that file, essentially they'll be able to see whatever your password is. The computer does instead is it creates what's called a hashing algorithm. Hashing is when a password that is entered in plain text is generated for a fixed length cryptic password depending on the format. So, for example, Windows computers store passwords in a type of format called NTLM. Then Unix based systems will use a salted hash. In a format called SHA 512 usually, sometimes 256, but usually 512. And this is in a process just make it more difficult for someone to find out what your password is. And when it comes to the different types of passwords, different companies use different methods for security. Microsoft puts all of their passwords in what's called the SAM file, and you can put in a security policy to make it so that those files can't be decrypted. And that makes it more difficult for someone to get access to your SAM file for the purposes of getting your password. When it comes to Linux and Unix based systems, so Apple and Linux, everything is stored in what's called a shadow file. And in this shadow file, they use a thing called a salted hash. So let's take a look at a hash to begin with so we can break down exactly how a hash works. Now, right here, you have user 1, and user 1 has a bunch of gibberish after its name, and this is what's called your hash. So these passwords right here are all Unix based passwords and Linux based passwords, and here this is the type of password that you would typically find on a Windows system. So what you see here is you see the first $sign and the number 6, followed by a couple of letters, another $sign, and then another set. So this right here tells you what kind of encryption algorithm your hash is using. So the 6 stands for SHA-512, the 5 stands for SHA-256, number 1 stands for MD5, and this one doesn't use any kind of specific hashing algorithm, so this is a completely different format. Now, after your first number and it tells you what type of encryption algorithm you're using, the next bit right here is called a salt. So Windows does not use salted hashes, and this actually has a really big security threat for what's called a rainbow table, and we'll be getting into that a little bit later. But right here, this salt makes it more difficult for you to be able to crack the passwords because you can't pre-compute the hashes in a rainbow table format. Now, after the salted hash, this is your actual encrypted password. And this one actually extends all the way out here. You'll notice that the 256 is shorter because it's using 256 bits instead of the 512 bits. And the MD5 is one of the weakest forms of protection that's available to a system. Now, when it comes to cracking passwords, we use a program called John the Ripper. And John the Ripper is built into Kali Linux. However, whatever version of Linux you're using, you can easily install this program. And the way that you would do that is you would use a command called apt install John. And so that tells you that you want to install this application called John. However, since it's already pre-installed, we're going to be able to just use it as it is. Now, the way John the Ripper works is it's a really specific format. Number 1, you have to go to the area that you want to crack the hashes. So we have a specific text file here. All right. So what I'm going to do is I'm going to change directory to my desktop and make sure that I see the file there. All right. And then the way John the Ripper works is that you use John and then the file that you want to crack. Right, and then whatever extension you have for it. And if we just leave it like here, what's going to happen is your system's going to do, John the Ripper is going to do a brute force crack on this file. So it's going to try every single combination to figure out exactly what your password is. And what you'll see here is I created a little timetable based off of some pretty generic numbers. Obviously, the hardware of your system can increase or decrease these times. But if I had a generic password like password and I tried to do a brute force attack, it's going to take roughly about 1 minute and 13 seconds with some decent hardware to be able to actually crack this password. the more complicated I make the password, the more time brute force is going to be. So for example, let's take a look at a password like because I'm Batman. This password, according to brute force methodology, would take roughly around 828 billion years to be able to crack. And so that's obviously not something that we want to do. So the first method when it comes to cracking a password is to guess. Guessing is always the easiest way to do it. So for example, let's say I have physical access to the system. What I want to do then is if I want to say, okay, I know the username of this system, well, why don't I just try guessing the password? The first password you guys should always guess for any system is password. And it just so happens to be the right password in this situation. So guessing is always going to be your first option whenever it comes to cracking passwords. Now, let's say that you don't know what that password is, or you tried a couple of guesses. Now you want to do a more dedicated attack. So if you guys remember from the previous tutorial talking about network cracking, I introduced the concept of a word list for you guys. So instead of me trying every single combination, what a password list does, it allows me to be a little bit more specific and on purpose. I'm trying only what I think is going to be the likelihood of the password being. So what we're going to do now is we're going to go back to the desktop, and we're going to crack this file using a password list. So what we're going to do is, again, and in this list, we're going to have a lot of different files. So I have these 4 files here, plus I have 2 in Windows format. And then this gibberish is just going to install. Also, the other thing is you have to make sure that you have your password file in the right format. So if, for example, I inserted a second colon here, it's not going to be able to read this. It's going to say that it's an incorrect format. As the same goes for here. If I inserted 3 or only 1 colon, it's not in the right format that it needs to be able to crack into this file. So what we're going to do is we're going to just start off with John. We know the file is going to be hashes.txt. After we do that, we're going to do the word list. So you do a dash word list. And then remember what we're doing here is we're saying, what is the path to my word list? So the path is, and you should always start off with this one first, unless you know, for example, you're in an environment where there's no possibility of this working. And an example of that would be if you're trying to crack into the passwords of a company that uses minimum requirements, like an uppercase, a lowercase, and a number. There's many passwords in this list that I'm going to use that don't meet those requirements. So I'm just wasting my time and possibly bringing attention to the fact that I'm trying to get into the system. So user, share, John, and then password.lst. So what this is going to do is it's telling John the Ripper to break into this this hash file with this word list. All right. And so what you'll notice is that one of the users was cracked. Okay. There's a lot of information here, and this information is really important. You can't just ignore a lot of this stuff. So this is going to tell you what you need to do next. Okay, so for example here it says that this hash file was also recognized as crypt, which means that it takes on 2 types of formats. So it says use the format equals crypt to force load these types instead. Now the thing that I've noticed is when you're using a virtual machine, unless you have a massive amount of memory allocated to your machine, using a format of crypt is usually not going to work. You're going to get a weird error message. So for example, let's say I did that right now. So I put in format equals crypt. All right, I get this segmentation fault, and that's saying that I just don't have enough RAM on my system to be able to do that. So the only way that you can get around the segmentation fault, what I've noticed, is to run it natively on your system or allocate a lot more resources to your virtual machine. But if that's not working, there's still a lot of other ones that it's noticed. So for example, it only loaded the hashes of type SHA-512 crypt, but it also saw this SHA-256 crypt. So now what I'm going to do is I'm going to put in the same command, except I'm going to use this type of format. So we're going to go right back into here and use this type of format. So now it found 1 password here and 1 password here. Now, if you want to see which passwords it still needs to crack, you can use a really simple command here. You can do John and then show from the document hashes.txt. All right, so it shows here that 2 of the hashes have been cracked and there's 6 recognized hashes that are left. We also see in this here that there is use the format nt-old to force load the NTLM hashes, right? Because it says that it found LM, NTLM. So this way it can do a lot. So let's go ahead and just go one after another. We've already done the 256. Let's do the MD5 next. And you have to make sure you can't just write MD5. You have to write it the way that it shows up here because the system is telling you it's recognizing it as a different encryption format. So you can't just, shorthand this. It has to be exactly the way the system tells you. So now I've got user 3 here. And then let's go and do the next one, which is the DES crypt. All right. And let's try the LM. I know for a fact it's not, not for a fact. I know it's not going to get the LM because the formatting of those is NTLM, which is used on the newer systems. And so what you'll see is this, okay? And this is a really good thing to bring up here. Now, if I minimize this and I open up this hashes file again, what you'll notice is it actually did a pretty good job of figuring out what those NTLM passwords are. So the way that these Windows passwords get segmented, you have the first part of here, which is your NT password, and the second part of here, which is your LM password. And so what it's done is it's found out that this one is 1, 2, 3, 4, 5, 6, and it did get that one correct. But if you notice for Harry and for password, which are these 2 files here, password 1 and Harry, it was not able to do it properly. It put it all in uppercase, which means that it's kind of figuring out the format, but it's not 100%. So let's go ahead and put that format into NT instead of the LM. And what you'll see here is that when I put in the NT format, it was actually able to get the entire thing correctly. Now, if I do the same command of John show, and it's the hashes.txt, you'll see on here that it found a couple of things here. So these it actually didn't crack properly. Over here you can see them, but it didn't do the full job. So let's try on that one the last format that it gave us, which was the NT-old. Let's see if that changes it, because the show format, file format for John, it should give you guys the full password like it does over here. Obviously here it hasn't figured it out. So what we're going to do is the NT-old. All right, so it says no passwords left to crack. So in this situation, you have a little bit of discrepancy here. Now there is another way of cracking NTLM passwords, and it's using a program called Offcrack, which is a rainbow table program. And I'll introduce you guys a little bit to Offcrack. However, it's a complicated program to use. So you're going to need to follow the step-by-step directions that I've laid out on how to get everything loaded onto your system, how to make it work properly, and everything like that for you guys, okay? Now, the last thing I wanted to cover when it comes to password cracking is going to be, like, for example, your shadow file. The shadow file is the most important file on a computer for getting access. So if I change to my Etsy folder, which is again the folder that has all the configuration files, and I do a cat on the shadow file, you'll see here that it has a lot of stuff, right? But here's a root password. So if I created multiple users, each user's password would be stored here. So if I have access to this file and I use John on this file now, all right, you'll see that it found the password for my root login. And that once you have the password for root, that's it. You've got 100% access to the entire system. There is no user on a system that's higher level than root. So once you have that, you can essentially do anything to your system. There's nothing that isn't restricted to you. So this is how you would crack any kind of file. Now, what you can do is, for example, let's say I don't have access to executing this file with the file permissions. And again, you can do that with the ls-la command. This will tell you who has access to what file. And again, we have the shadow file, and it shows that only root has access to read and write. Okay, and that's me. However, if I'm part of the group, I can only read, I can't write to it, right? Which means that I won't be able to do some of the things that I do. Well, as long as I can read the file, I can copy it in its entirety, and I can just create a new text file. And so if I save this text file on my desktop again, and let's call this one root.txt, and I'm going to re-navigate back to my desktop. And you'll see that root file is there now. What I'm going to do is the same thing, John, and then root.txt word list equals user share John password.lst. You can see here that, let's see. Oh, since I've already cracked this hash, now this is another thing to bring up. John the Ripper actually stores any kind of cracked hashes. So because that hash was exactly the same and I've already cracked it in the shadow file, in this situation, if I want to see it, I would do the John show, and it's going to be the root.text. And so it says that one hash has already been cracked and it's already giving me the password. So even though I put it into a brand new file, the fact that that specific hash was exact and it was copied into the new file, it's already cracked it, so you just have to show it in that situation. All right, so that's it for the actual password cracking. Now, what I want to go into is the actual password list. There's a very, very big list that's built into Kali Linux, and this list is called rocku.txt. Here's the thing about word lists. The shorter your word list is, the faster it's going to crack, okay? And I'll give you guys an example of that. If I go into my user share folder, there's going to be a folder here because Kali Linux is a penetration testing tool. There's one called word list. So I'm going to cd into word list. And you'll see that there's this file right here called rocku.text.gz. Now the rocku.txt is just a text file. The .gz is a type of compression. So the way that you have 7-zip and you have WinZip and all those types of programs, you would just use the built-in program, which is Gunzip, and then you would do rocku.txt. And so what this is going to do is it's going to uncompress that file. And now you'll see that rocku.txt is here. Now, if I cat out rocku, you're really going to see how long this file is. This takes a pretty decent amount of time to load because of just the massive amounts of passwords. Now, the way that the password list is going to work is you have to remember it's going to go through that text file. It's going to read a password, use the encryption method that you specify to convert it into that hash format. It's going to compare the hash with the hash that's in the file and tell you if that hash matches. If it does, it's going to report back what that password was. So for example, let's take something like this password here. What it'll do is it'll convert this password into the hash, compare it to the hash file, whatever you've specified, and it would return back to you, okay, this is the password where the hash is matched, so this is the password period. Okay, now if you look at this list, password should be pretty low on this list, which means that if I was to use the same type of cracking format, all right, and I'll generate a quick password for you guys here to go ahead and test this out. What we're going to do is we're going to go to a password here. Okay, so I'm going to really quickly make this password into a hash. And I'll use the SHA-512 method. And we'll go ahead and do that password. So 382.222.83. Okay, I'm going to take and copy this hash. I'm going to put it again in this root file. All right. So once this is saved, let's go ahead and try this now. And remember, it's always important because you're going to type in the full command and you're not going to be able to do it. If I had run that password crack right here, it wouldn't have worked because my hash file is over here in my desktop. So you have to always navigate to it, okay? So let's start this again. So John and then root.text. We're going to use a word list. Now in this situation, my word list location has changed. All right, so the word list is no longer in user share. This word list is in, it is in user share, but it's not in the John folder. So it's user share and then word lists. And it's under rocku.text. All right, so if you remember that John password list cracked my passwords really fast. You can even see how long this has been taking, what percentage of your list you've done. So what I've done right here is we've been going on so far, and it's going to give me an output of how long it takes to do everything. But if you're looking at the ETA for it to go through the entire list, it's going to take 20 hours to go all the way through Rocku just because of the massive number. And every time I hit any kind of character arrow, I'm doing up, we've only gotten 14%, 0.14% of the way done of this entire list. So using, you can say, all right, I'm going to make a list that has every known password, period. Well, the problem with that is eventually you're going to run into the issue of how long it's going to take to crack the password. And again, if you know for a fact your organization doesn't allow passwords that don't meet a certain criteria, using a massive list like Rocku is just going to be a giant waste of time, and it's going to be more chances of you getting locked out or you getting caught doing the password cracking. And when you're doing a pen test, obviously you're doing it ethically, but you still don't want to be caught. You want to pretend like you're a hacker getting into a system. And so now you'll see that the time is increasing because it's trying to get a more accurate estimate. And we're not even 1% of the way done with this list. And it's taking a really long time to get that password just because of its location. Now, what a rainbow table does, a rainbow table is taking all of these passwords and it's pre-computing them into a hash. Okay, so what it's doing is it's taking those passwords that are in the word list, and instead of computing them into the hash at the time when you're requesting it from a password program like John, it's doing it all ahead of time. All right, and there's a program specifically designed for this creation. It's called WinRT, and let me go ahead and get that running on here. I'll have to download it. So it stands for WinRT. I spelled that wrong. WinRT Gen. All right, and this right here is a product that's designed for creating rainbow tables. All right, so we're gonna go to WinRT Gen, and it's just a zipped file. So I'm going to open this up. It'll ask me to extract it. All right, so the way that WinRT Gen is going to work, and let me minimize this stuff here. All right, so it's going to say I want to create a rainbow table, and again, a rainbow table it's going to be a brute forced table. They're going to try every possible combination. It's not going to come from a word list, but it's going to be every possible combination to crack. So I'm going to add a table. And it tells me what kind of hashing algorithm do I want to use. Now, I'm not going to use any of these types of hashing algorithms. I know that SHA 512 is a really good type of encryption. However, if you remember, Linux uses the salt. The salt is a randomly generated value by the system that automatically puts into your password. Now, it's impossible to predict what that salt might be, and it's impossible to prepare for every single possible salt that's on the market. And so because of that, you would never use a rainbow table against these types of encryption methods. They're usually not effective. What is effective though is the NTLM, and again, remember this is the type of encryption algorithm that Windows machines use. And since Windows makes up about 90 to 95% of the market when it comes to computer systems, this is the one that you would really want to use. So let's say your computer, you want to create a list that is anywhere between 1 to 8 letters. Okay, 1 to 8 characters. So we know that most people, the way they do it is they use anything around an 8-character password. So this password, if I wanted to create a 1 to 8 character using only uppercase letters, all right, and I can benchmark this, this is going to have, it's going to take 6 hours for me to do this. The success probability is a 33%. Roughly 33%. So 1 out of 3 passwords are going to fall inside this list, and it's only going to be for uppercase. So this is the biggest problem with rainbow tables. It's going to take me 6 hours to do a list that only has a 33% chance of success. So what if I did something a lot more complicated? So what if I did uppercase and lowercase at an 8-digit? If I benchmark this, this thing barely has an 18% success probability. It'll still take me 6 hours to do, and it's going to take 610 megabytes of storage. If I wanted to make this be very accurate, let's say I wanted it to be a 98% accuracy, we're looking at 5.9 terabytes of total storage. And if you round up, it's essentially 6 terabytes of total storage that it's going to take up. With that much data being stored, and if I benchmark this, this is going to take 7 years to calculate with my current hardware. And, you know, to give you guys an idea, I'm using an i5 processor, quad core here, and it's going to take around 7 years for me to calculate this. If I wanted to get even crazy, because this doesn't do symbols, it doesn't do numbers. If I wanted to do a very, very like insane list, so let's say I did mix alphanumeric and symbol. All right, so it encapsulates all of these characters in a 1 through 8 with an accuracy level of 50%. It's still going to take up to 6 gigabytes. It's still going to take the 7 years, but because I'm adding all this extra stuff, now it's only half as effective. If I want this list to be 90%, 96% accurate, it's going to take 77 years to generate. So this is the really big problem with rainbow tables. They are efficient when they work. However, it's really long process to generate. So for the most part, the program that I like to use is called Offcrack. Offcrack is a very good program for cracking NT and LM hashes. It's available for free to download on multiple platforms. It runs on Windows, on Linux, and on Mac OS. But once you download this program, you also have to download the rainbow tables for it. So you have rainbow tables for XP systems, and I know people are thinking, well, XP is outdated. There's a lot of companies that specifically still use XP because they don't want to invest in their infrastructure or redesign the programs, which is a really big risk to a lot of companies because Microsoft no longer supports XP. So any vulnerabilities that were there at the last day that they supported it still exist. On top of that, you also have these Vista tables, and these are surprisingly accurate because it combines a little bit of brute force with the tables that they've generated, and it takes up a lot less space. So I've used these tables to a really high level of accuracy. Now, these tables, the way they work is these are free to download. These, however, that are more accurate, again, it'll tell you the character set, it'll tell you the password lengths, and it'll tell you the success probability when using these tables as well as the total size that it takes up. These are all paid for. So if you click on this, you can get an idea of how much it's going to cost. If you guys want to do this, this is up to you. It's about $1,000 to download, but this is another option that you have. Now, when you do install Offcrack, you do have to load the tables in. What I can do for you guys is I can link a YouTube video that shows how to use Offcrack. Again, it's not a program that you guys are going to see used that often because a lot of companies now know the vulnerabilities that exist on storing hashes directly on the computer. So people are now using two-factor authentication. They're using storing on the cloud. So this is a little bit older style, but it's still important because some smaller companies aren't switching over to cloud-based encryption, or they're not switching to cloud-based. So typically what people will do now is they'll social engineer passwords because the formats that they're storing them in is just a little too much. And if you look at this RockU list, it's 2% done, and it still hasn't gotten that password I created in this root text file. So be really careful about which password list you use. You can generate your own password list. I will be making a separate video for that because there are a couple of different programs to do it. However, you can also do it through Terminal. So I'm going to show you guys a couple of the most efficient ways to do it. However, this is the password cracking tutorial. All right. If you have any questions about password cracking, because this whole subject can get complicated, there's a bunch of other YouTube videos available as well. Anyone in the cybersecurity lab will be more than happy to help you guys out. We do have an excellent course on campus called Penetration Testing that's taught by Professor Pope, and this is where I learned a lot of these techniques, and he's very passionate about penetration testing and computer security, so he's another really great resource to learning more about this information. All right, that's it for this tutorial. Look forward to the next one, guys. Thanks a lot.